Welcome back to Kamal Kunj Home Academy, Counter with Mathematics. In this session, we will discuss the Pythagoras Theorem. According to this theorem, in a right triangle, the square of the length of the hypotenuse is equal to sum of the squares of the lengths of the two legs. Here, given a right triangle, ABC, what is given here, given a right triangle ABC in which angle ABC is equal to 90 degrees. What is to be proved? To prove square of the hypotenuse, it is AC, AC square is equal to sum of the squares of the legs, two legs, AB and BC. AB square plus BC square. Now prove. There exists a segment BD perpendicular to AC. There exists a segment BD perpendicular to AC. One and only one perpendicular can be drawn from a point to a line. Let us consider one-to-one correspondence ADB and ABC. Angle ADB is equal to angle ABC E each equal to 90 degree. And angle A is equal to angle A. Any angle is congruent to itself. It is common to both. It is common. Therefore, triangle ADB is similar to triangle ABC. Reason is angle similarity. This implies that AD upon AB is equal to AB upon AC. This implies that AD into AC is equal to AB square. Let it be number 1. Again, let us consider one-to-one correspondence between BDC and ABC. Here, angle BDC is equal to angle ABC, each equal to 90 degree, and angle C is equal to angle C. Any angle is congruent to itself. Therefore, triangle BDC is similar to triangle ABC. The reason is angle similarity. This implies that since these two triangles are similar, sides will be proportional. BC upon BC equal to BC upon AC. This implies that BC into AC is equal to BC square. Let it be number 2. From 1 and 2, we get AD to AC plus DC into AC equal to AB square plus BC square. This implies that AD plus DC into AC equal to AB square plus BC square. This implies that AD plus DC is AC. So AC into AC is equal to AB square plus BC square. This implies that AC square is equal to AB square plus BC square. Hence the result. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.